world $sign in my output, but no, that's just kind of a remnant of my prompt starting with a $sign. And this is a little nitpicky, but this just doesn't feel right, doesn't look right. It's not quite correct. So how can I go about fixing this? Well, here's where, at least initially, it's going to take some introduction to like just new syntax in C to fix this. Like the simplest instinct might be to do this. Well, let me just hit enter like that. But this should soon, if not already, rub you the wrong way. Because in general, we're going to see that programming in C and in Python and other languages tends to be line-based. Like you should really start and finish your thought on one line. So if you're in the habit of hitting enter like this and sort of finishing your thought on the next line, generally programming languages don't like that. So this is in fact not going to do what we expect. And just to show you as much, I'm going to do this. Let me go back to my terminal window here. I'm going to rerun make hello after making that change, enter, and there we have it, like the first of our erroneous outputs. And it's yelling at me. It's missing a terminating character, and there's some red in here, some green, drawing my attention to it. Sometimes these error messages will be straightforward. Sometimes you're going to like rack your brain a bit to figure them out. But for now, I've kind of spoiled that obviously enter is not the right solution. So let me clear my terminal window just to hide that error. Let me delete this. And let me propose now that I add this incantation here. So \n, it turns out, is going to be the sort of magical way of ensuring that you actually get a new line at the end of your output. So let me go ahead now and rerun make hello, because I've changed my code. I need to now recompile the source code to new machine code. /hello, and now there is the canonical hello world program that I hoped to write in the first place. So for now, don't worry about the include. Don't worry about the standard IO. Don't worry about int or main or void or the curly braces. Focus primarily on line 5 here. And over the course of today and next week, we'll start to tease apart the other characters that for now you should take at face value. Questions, though, on any of the steps we've just done? Yeah? Sure. Why is the \n inside of the quotation marks, if you will? So shorter answer is like that's just the where it needs to be, because inside of the quotes is the input that you want printf to output to the screen. So if you want printf, this function, to output a new line, it must be included in the quoted text that you give it. Exactly. \n is a special pattern that printf no means, OK, I should move the cursor to the next line. Good question. Other questions on any of these steps? Yeah? A good question. So what if you actually want to print \n? Things get a little tricky there. Let me go ahead and propose that we do this. So it turns out, and this is often the case in programming, when you want a literal character to appear, you actually put another \ in front of it. But this is not going to be something we do often. But there is, in fact, a solution to that. But let me propose that beyond that now, we sort of compare it against what we've actually done. So here is the first Scratch program we wrote with the green flag there. Here, recall, is the mental model that I proposed we have for almost everything we do, whereby functions are just an implementation, say, in code of algorithms, step-by-step instructions for solving problems. The inputs to functions, recall from last week, are called arguments, or in some contexts, parameters. And sometimes functions can have side effects. Like last time with Scratch, there was the speech bubble that magically appeared next to the cat's mouth as a sort of side effect of using the say block. So just like this, then, we had the white oval as input. The say block was the function last week, and then we had this here side effect. Well, how do we compare these things left to right? Well, here's the say block at left. Let's compare now to the C code at right. Notice a couple of things to sort of adapt from Scratch to C. Print is almost the name of the function. It is technically printf, for reasons we'll eventually see. Notice the parentheses in C are kind of evocative of the oval in Scratch. And that's probably why MIT chose an oval, because a lot of languages use parentheses in this way. You still write hello world, just as we did last week in Scratch. But per our demo thus far, you do need the double quotes, and double quotes, not single quotes, double quotes on the left and right. And in order to get that new line, you need the \n. And one more thing is missing. Yeah, the semicolon to finish your thought. So all of these sort of stupid things now that honestly you will forget initially if you've never programmed before, but you'll soon, within days, within weeks, develop the muscle memory where all of that stuff just jumps off the page right at you. All right, so these escapes, this \n is generally known, just so you know, as an escape sequence. And so \n allows us to specify a character that might otherwise be hard to type. But let's tease apart some of the other things atop that function already. So include standard io.h. It turns out that in C, a lot of the functionality that comes with the language is tucked away in separate files. So if you want to use certain functions, you have to tell the compiler, hey, I want to do some standard input and output. Like I want to print some things on the screen. And that's because for now, you can think of printf as living in this file, standard io.h. That's a bit of a white lie for now, but in standard io.h is essentially a declaration for printf that will teach the compiler how to print things to the screen. So #include here simply tells the compiler before it does anything else, essentially go ahead and find on the local hard drive a file called standard.io.h and kind of copy paste it there. So I know now about printf. So this thing, this .h file, is what we'll technically call a header file. And if you've ever heard this word, especially if you have programmed before, it represents essentially what we'll start calling a library. So a library in the world of programming is just code that someone else wrote that you can use. It's usually free and open source, which means you can literally see the code that someone else wrote, or sometimes you pay for it. Sometimes it's closed source, which maybe Microsoft wrote it. They won't show you the code, but they will let you use the zeros and ones. So libraries are super useful because honestly, even I don't really know how printf works. I've taken for granted for 25 years that if I use printf, stuff prints on the screen. But someone smarter than me had to actually write the code in C that figures out how to get the H, the E, the L, O, and so forth onto the Mac screen, the PC screen, the phone screen, or somewhere else. So libraries allow us to sort of stand on each other's shoulders, and so that someone else can do the hard work, and we can now solve problems that are more interesting to us, not the basic commodity stuff that everyone might want in their code. So again, library is code that someone else wrote. A header file in C is just a file ending in .h that gives you access to the same. And so for instance, if you want to learn more about these, there are what are called in the world of programming manual pages. And these are textual files, like a documentation of sorts, via which you can just learn how a function works and how you can use its inputs or arguments. The reality is they're written for folks who aren't in CS50. They're written for folks who aren't just learning how to program. They're written for and by folks who have been programming for years. And so frankly, they're a little hard to understand. And so CS50 has its own version thereof at this URL, manual.cs50.io, where you'll see not only the official documentation for C, the language, but also staff-written simplifications in layperson's terms, what all of the various popular functions are, what their inputs and what their outputs are. So for instance, under standard.io.h, you can actually go to that website. You can go to a URL like this, where standard.io.h is in there, and you can actually see the documentation therefore. So let me go ahead and do this. I'm going to go ahead in my browser here. I'm going to go to manual.cs50.io. And let me go ahead here and select those functions that are frequently used in CS50. And under standard.io.h, you'll see a bunch of functions, only one of which we've even discussed, called printf. I'm going to click on printf there. And you'll see an interface that at first glance might be a little overwhelming, but it's going to start to look more and more familiar. So first of all, you'll see that if you want to use printf under synopsis, you need to include this header file. Like you literally copy and paste that line into your own code. You'll also see this, which for now is a bit arcane, but this is kind of a hint as to what the function is going to look like. But more on that soon. But more importantly, you can read a description about it. And because these descriptions, when you're in less comfortable mode, are written by me and the course's teaching fellows, teaching assistants, and course assistants, you'll find them to be much more in layperson's terms. And so long story short, rely on this site when you want to learn how to use some function and also what other functions exist. In fact, if I go back to the main page here, you'll see that there are all of these functions like are frequently used in CS50, and there's hundreds more that come with C. But learning a programming language is not about learning all of those, but rather just getting a sense of where you find answers to questions when you do want to try something new. But what is important to know for CS50 today is that we have our own header file called cs50.h, which has functions that we have written just to make life easier in the first few weeks of the class. These are training wheels that will eventually take off. But it turns out in C, especially if you've programmed before, it's actually really hard and annoying just to get input from users, to get them to type a word or a number or something else. Like C does not make this easy, in part because it's one of the earliest languages that wasn't zeros and ones. So you have to do a lot of the heavy lifting yourself. But we'll put on these training wheels today and for a few weeks so that we can focus really on the intellectually interesting ideas of C and programming without getting bogged down in certain weeds that we will come back to before long. So for instance, CS50's own documentation is there at that URL. But within the library are these functions. A function called getString to get a string of text. String is a synonym for just text in a programming language. So getString will prompt the human for a string of text. GetInt is shorthand for getInteger if you want to get a number from the user. GetFloat is a little more arcane. Get a floating point number, like a real number with a decimal point in it. And ... there are others as well. So this is to say, within CS50, we've got some user-friendly functions via which we can actually get some input. And let's go ahead and use one of these, for instance, getString. Because recall that last week, our second program in Scratch was this one here, where we didn't just say hello world, we said hello David, or hello Carter, hello Yulia, whoever it was typing their name in. But to do that, we needed this ask block in Scratch, and then we use the say block, and then we use the join block to kind of make all of this work. So let's translate this program now into C, because it's a little more interesting and representative of the kind of code we'll start to write. But we need a slightly different mental model. Still have a function here, which is the implementation in code of an algorithm. We still have some inputs called arguments. But previously, I said that the say block and in turn printf have side effects, which is just something visually, typically, that happens on the screen. Other functions actually have what we called last week return values. And this is kind of analogous to a function maybe doing something for you, writing down the answer on a slip of paper, and then handing you, the programmer, the slip of paper to do whatever you want with it without just broadcasting it to the world with like a speech bubble on the screen. So a return value is germane for a program like this because recall, when we used the ask block and I typed in my name, where did my name end up initially? It didn't go on the screen yet. Where did it end up? In an answer puzzle piece. And that special oval puzzle piece I claimed at the time represents a return value. So the sort of metaphorical piece of paper that the answer is written down on so that I can then use it later. So that's what we want to get to now in C, a return value that I can then do anything I want, whether it's printed to the screen, change it in some way, save it in a database, or anything else. So here, for instance, is what we did with Scratch. The input to the say block, or the ask block, was what's your name, quote unquote. The function, of course, is the ask function. And the return value was answer. If we now consider how we might translate this to C, it's going to look a little weird at first, but it's going to follow a pattern today, next week, the week after, anytime we do code like this. So getString, I claim, is going to be the most analogous function in C to the ask block. And to be clear, this is a CS50 specific thing, training wheels of sorts, but we'll show you in a few weeks what this function is doing and how you cannot use it moving forward once you're comfortable with the language itself. Notice I've put parentheses left and right as sort of a placeholder for user input, and that user input is going to be what's your name. But I can't just put what's your name in parentheses. What do I minimally need to add in there too? Yeah, so the double quotes left and right. So let me go ahead and add those in. I left a space here, not for a new line. I could move the cursor to the next line, but I minimally at least want to move the cursor at least one space over, just so it looks pretty, so that when I'm prompted for my name, there's a space between the question and my answer. But it could also be \n. That's just an aesthetic choice on my part. But what do I do with the answer that comes back from getString? This is where the text is going to look different today. In C, you start to use an equal sign from left to right, respectively. And on the left, you put the name of the variable in which you want to store that return value. So a return value is kind of a conceptual thing. You can do with it what you want. And if I want to store it longer term in a variable, like x or y or z in math class, I can just give it a name here, x or y or z, or more reasonably, answer, or any other English word. No spaces, generally lowercase, same heuristics as before. But this means now Ask the user what's their name. Whatever they type in, go ahead and store it from right to left in this variable called answer. But C's not done with us yet. If you've learned Python or certain other languages, you'd kind of be done writing code at this point. In C, though, you additionally have to tell the compiler what type of variable you want to use. So